Part 1, Wireless Networks. My name is Chris Scanlan. I'm a sales engineer at Capital Sales, and I just wanted to thank you guys for taking the time out of your busy day to learn a little bit about wireless. So let's get started. First of all, networking is the foundation. In 2015 and 2016, the fastest growing categories were home networking and IT. Okay, just keep that in mind. It is a network world. We need to know it. It's a love-hate relationship, but if you want to keep moving forward, we got to know networking. And the most common development is what are integrators installing? Whether you like it or not, again, you got to tie into IT and into networking. So by doing so, everything's going IT, everything's going networking, and everything's going wireless. So that's why we're doing wireless first, because it's the most popular, as well as everybody wants it. So we need to know how to do wireless in a properly how to do wireless. So let's get into wireless networking. First of all, a little bit about wireless. Wireless protocols. There is 2 different frequencies. We've got 2.4, which is single band, or we've got dual band, which is 2.4 and 5 gigahertz. The 2.4 gigahertz goes twice the distance because it is half the frequency. So lower frequency, longer wavelength, it's able to go through and penetrate through obstacles better. So it's going to go, because it's twice as low, so it's going to go twice the distance as 5G. But 5G is much faster. Okay, it's less crowded, shorter wavelengths. Everything runs right now on 2.4, not just wireless, but there's other devices that run on 2.4. So keep that in mind. 2.4 is very congested, so 5 gigahertz is much faster, but you lose distance when you go to it. Okay, 2.4 has 11 channels, but only 3 are non-overlapping channels. So whenever you're setting up a 2.4 gigahertz system, you want to make sure you're on channel 1, 6, or 11. So those are the only non-overlapping channels. And then on the 5 gigahertz, there's 8 non-overlapping channels. So much more agile in the 5 gigahertz range and a lot less congested. So the biggest question I always have, and everybody has when you go into this, how far does it go? How far can you wireless go? When you go into a house, how do I know if I'm going to get wireless? And the answer is it depends. You can't put an exact number on a wireless because, again, it's an RF frequency. There are so many determining factors that you can't say it is going to go this. And it's not always going to go that distance. So how to know that, first of all, is some of the characteristics. Wireless transmit output power. That's going to determine how far it goes. Not every access point is the same. Not every wireless router is the same. So you want to make sure you know what the wireless transmit power is. That's going to give you signal strength. Also, physical placement. Where is it installed in the house or in the commercial install? Also, number of access points. There are so many environmental factors like interference, construction materials that determine the distance. That's why you cannot say it's going to go exactly this. It's going to always be able to do a 50-foot, a 5,000 square foot house. You never know because construction materials are huge. I just did one for somebody, and they had marble floors. Well, you're not going to be able to broadcast from one access point to the downstairs basement going through thick marble. It's kind of like concrete. Things like people put a wireless router. Well, everything is ran, wiring-wise, is ran down to the utility room. Well, what's in the utility room? You've got a lot of times washer and dryers. You've got your furnace, maybe heat exchangers. You got a lot of metal ductwork. Wireless getting out of that room is going to be very hard, very difficult, and it's going to cut the wireless signal strength and distance down astronomically. So being able to understand the construction of the building is going to really help with placement of the wireless router and or wireless access points. Now let's first of all go talk about output power. I'm going to use Luxel as a lot of these because it's one of the lines that we sell. They do make some very nice access points, and they're very forthcoming on distance and speed. So we're going to use Luxel as some examples. The Luxel APs provide 1,000 milliwatts of power, 1 watt. That's 10 times the output power of a traditional AP, 2 to 3 times for real coverage increase. Okay, and we're going to get into coverage here in a bit, but standard client devices, meaning your phone, your laptop, the devices that are out there roaming, they're only 13 to 50 milliwatts of output power. Okay, that's going to give you can see right there on the side. So traditional APs, wireless routers, standard small APs are 70 to 100 milliwatts. Your standard high-powered AP that you see are anywhere from 400 to 750 milliwatts. And then the Luxel high-powered access points are 1,000 milliwatts, which is actually the maximum that is allowed without getting licensed. So 1 watt is the maximum output transmit power that a wireless device can do without licensing it. Okay? So just keep that in mind. You're not going to get any stronger than that without having to go into licensing. So let's now get into signal strength. What's my signal strength and what does it mean? Signal strength is measured in negative dB, okay? Negative dB is how far from the device, right? 0 dB is perfect. You know, that's a 0 dB loss. So signal doubles every negative 3 dB. So if you go from 33 to 30, you're actually going to get double the distance, so double the power. Signal is rarely higher than negative 30 dB, okay? Unless you're standing right under the access point a few feet away, you're not going to get much more than negative 30 dB. It's just the way it works. So what is good signal strength? Always shoot for 70 dB or better. Normally when you're walking around, you're going to see anywhere from a negative 50 to a negative 75 dB range. You always want to try and get above 70 dB, negative 70 dB. If you start going below 75 dB, you may be able to see the signal, but you may not be able to transmit back to it. So you always want to make sure your client device has got a 70 dB signal or better. Okay. Anything below that, again, like it states right here, is the slippery slope. You may be able to see it, but you may not be able to transmit very well back and forth. So you always want to make sure you're above 70 dB. Now, let's just get this out of the way, because everybody comes and you look at the boxes, you go and you say, well, this one says it's faster, right? Nothing is ever advertised as what's on the box. Real speeds, you're looking, if it's a 1900 AC access point, 30 to 50% of that max number. Okay, let's just get that right out there. You're not going to get 1900 megabits per second on a 1900 AC access point. It can happen. So let's just get that right out there. Numbers don't always matter, okay? Wi-Fi can't transmit and receive at the same time. It's a half duplex, okay? So by meaning that, it depends on a lot of variables. It's not full duplex. It's not transmitting and receiving at the same time, so it's going to cut that down automatically. Speed depends on signal strength. It's going to depend on channel, RF interference, number of clients. Number of clients, you got a 1900 AC access point. You have 50% of that, and then every device is using now, let's say 5% of that. It comes down astronomically. Okay, so number of clients is a huge factor. Also, AP and client specifications. Some may only be able to transmit 100 megabits per second. Every environment is different, so you never get what's been advertised in the box. Customer education is key. What I mean about that is that you need to explain to the customer what they're going to get. You know, they're not going to get 1900 AC, and explaining how wireless works is going to make it so much easier to sell to the customer and why the Apple router, why they need something better than the Apple router, and they need to put in a multi-access point system. Customer education is key, and this webinar is going to be available for download as well. So I'm going very fast. If you guys miss anything or want to review it later, all of this info is going to be downloadable. It's also being recorded, so you can check it on our YouTube video as well. So max versus real speeds. Real Wi-Fi speeds. We'll just take a 1700 AC 3x3 access point, 5 gigahertz max. That's 1750 across the board. Okay. And how they get that is 1300 on the 5 gigs, 450 on the 2.4 gigs. That's 1750. Now, 5 gigs max is 1300, but the real speed, you're only going to get about half, like we said, 30 to 50%. That's about 500 megs a second. Okay. On the 2.4, you're probably going to get about 120 megs a second. So you can kind of get an idea, and this really breaks it down, and to be able to show the customer this is, and maybe most customers this may go right over their head because most of them don't know what a megabit is, but this really kind of puts in perspective when somebody calls and says, hey, I'm not getting what I should be getting. This is really how it works, okay? And again, when you look at a 1900 AC, you're thinking 1900 megabits per second or 1750. That's not 1750 on the 5 gigs and the 2.4. That's split up between them, okay? So keep that in mind. Let's go into measuring signal strength. There's a lot of tools out there to measure signal strength, and this is something that you need to have to be able to do an on-site client visit or troubleshooting. Insider is extremely nice product, software that's for Windows, Mac, Android. They don't have it for iOS. Acrylic Wi-Fi is Windows. Wi-Fi Explorer for Mac. Apple Airport is iOS. Wi-Fi Analyzer, and Wi-Fi Overview. Okay, there's other ones out there. These are some of the ones that work very well that are either free or nearly free tools to be able to use. So when you have the Insider and when you have your tools to measure signal strength, how are you going to do that? You're going to bring in an access point. When you do a site survey, you're going to bring in an access point. You're going to place it in the house. You don't need to have a wireless internet connection to do this, but you're just going to take a PoE injector, plug it in, set it where you think it's going to be, and walk around the house and see if you've got a negative 70 dB strength or better. This right here, they place it, let's say that's where their office is, and they have a wireless router, they want to put it there. Well, if you had Insider, you had one of these tools to measure signal strength, you could easily plug in the wireless router, walk it, and know exactly that, hey, this isn't going to work. I need to add another access point, or I need to relocate the wireless router. By doing this, you're going to now know ahead of time when you're walking in. You're being preventive. You're being the custom installer by telling the customer, this is what you need. Okay, this is how it needs to work. So let's talk about propagation, okay? Because even though it's omnidirectional, we talked about construction materials. Here's a great view on what limits performance. Just because that map looked like it was going to cover everything, certain walls are going to, maybe it's a window on the wall, maybe it's, metal, elevators, insulation, water features, stone, stucco. All of this stuff really makes a huge factor on environmental for signal strength. We had one where it was, I had one that couldn't figure out what was going on, and it was the mirrors on the doors. They were lead-lined mirrors. Well, Wi-Fi doesn't broadcast very well through lead. Makes a huge difference. So just keep that in mind, and nothing works better than bringing in an access point, plugging in, and actually doing a site survey and walking it around. So when you need to use more than one access point to cover the house or the commercial installation, you're going to have wireless roaming, meaning when a device goes from one access point to the other. Okay? Most of the time, there's issues with this. And the way wireless roaming works, it actually transfers from one access point to the other in the same wireless LAN, meaning the same SSID, same password. The client does not have to disconnect from one access point and connect to the other. Okay, now, the way wireless roaming works, it is not the network's job to have it switch. And here is how it works. It is a client's decision, okay, meaning it is the phone's decision to disconnect and reconnect to another access point. So how do you make the phone do what it's supposed to do? You can't just have the access point drop it. You actually have to have the phone do it itself. So with client-only roaming, it's connected to AP1 at a negative 45-degree signal because the other access point is at negative 75 dB. So it may be at a better signal for the other AP. The problem is it still has a negative 70 dB signal from access point 1, so it never drops that access point. You may be standing right on another access point, but it sees the other access point, so it holds on to it still. Everybody's seen this, and this is what happens with wireless roaming. Now, to be able to fix that, that's what should happen. How do you solve the issue? With one AP, there's no wireless roaming issues, right? You can cover the whole house, no problem. What you need is a wireless controller. Luxil has one of these. There's only actually a few wireless manufacturers and network manufacturers that really do right with an actual wireless controller to manage every client device on the network, because that's what has to happen. Luxil does it. Cisco does it. There's a couple others that do. Not a lot. And that's really the only way to do it. You can't have it done inside the access point. You have to have a central device be able to control it to get really a zero handoff. And what happens is the access point sees all access points, or the client device sees all the access points. You can tell that when you grab your phone and you scan. It sees the signal strength. It tells the wireless controller the signal. The access points tell the wireless controller the signal strength on which one it is. When it moves to the other, the client device, again, sees the signal strength and tells the APs. APs tell the wireless controller. The wireless controller actually bounces to the one access point and tells the wireless or the client device to jump to the next. Okay, it's requesting. It's not cutting the communication off of the AP. You can't turn off the AP. It actually has to request and the client device to switch access points. Now, there are a ton of support access points by Luxil if you want to use the Luxil wireless controller, and I would definitely recommend doing that. The 1510 access point, 1410, 310. The 1500 and the 1210 are discontinued, but they're still supported. 1230 and the 1240 outdoor access point are all supported by the wireless controller. So now that we got wireless access points and we've got zero handoff, zero roaming taken care of with the wireless controller, orientation, omnidirectional overlap, and somebody asked this question, and I didn't mention anything because we were going to get to it. Orientation doesn't matter because it's omnidirectional. First floor, second floor, third floor, orientation, since it's omnidirectional, it doesn't have to be. But overlap zones, you want to be at least 60 to 70, negative 60 to negative 70 dB overlap. Again, we said you never want to go below 60 dB or 70 dB, ideally. Some go down to 75, but again, that's getting to that border of signal strength. So signal strength is one thing that you can control. You need more signal strength, you put in another access point. It's that simple, guys. You need more strength, you're going to put more access points in. Okay. So before we jump into it, you can't do too much signal strength because it's not a constant broadcast. It actually does jump back and forth. So by doing so, even if there is a little overlap with the zero handoff and zero roaming, you're not going to have issues. It's better to have too much coverage than not enough. Okay. Now, with that being said, there are a lot of devices that we didn't talk about today, and I'm going to go into more questions and answers here in a second because I did cover a lot. I'm sure there's a lot of questions. Before we do, next Tuesday, we're doing another webinar, which is going to be on routers, switches, unmanaged versus managed switches. And with that in mind, we do have a lot of sales right now on both Luxel and Ingenious, which is another network line that we cover, or that we carry. So I wanted to put some of the sales up there right now that you can see. Very great router, the Epic series, the new ABR 4500, XBR 4500 are great routers. They have a wireless controller that's built into them. Also, 8-port switch, 24-port switch by Luxel, and the Ingenious outdoor access point. It's a dual band access point. Very nice products. So if you want to prepare for next week, I would definitely recommend getting, if you haven't played with the ADR or the Luxel products, definitely get them in. If you need some outdoor access points, Ingenious does make a very nice outdoor access point as well. So also, before I start jumping into the questions, above and beyond this webinar, if you guys need any help with anything or have any questions, Luxel has some very nice IP courses. IP networking basics, wireless network basics, wireless controller and roaming we just talked about, but if you want to know more, there's more info in that. Secure remote networks, VLANs, guest networks, as well as internet management. So take advantage of some of the tools out there above and beyond this webinar to grow your knowledge too. Now, again, we're at 9:22. Went very fast, covered a lot of info. Again, this is why I couldn't jump into routers or switches. We're going to go into some of these questions here real quick. And before I get going, if I don't answer some of your questions, or if you guys have more questions when I get off, feel free to reach out to me. I'd be happy to discuss more. Maybe it's a specific project. So let's take a peek at some of the questions. What is the ramifications of cross-channel in 2.4? Cross-channel in 2.4 is a very interesting, some devices do not actually, some client devices do not work in cross-channels, where it can actually only see 1, 6, or 11. Other times you may have interference on both channels because you are cross-channel, going into some cross-channels. I would definitely recommend just to stop yourself from maybe having issues in the future, stay with 1, 6, or 11. No matter what, those are your channels you're going to want to try and stay with. Not exactly, the network can't support it, but some client devices may not be able to support it. So that's why you really want to stick with those channels right there, 1, 6, or 11. What should the overlap signal be and what dB? Like I said, we covered that at the very end. At least -70 dB, if not better. It's better to have too much signal overlap because it will propagate between the two, and you shouldn't have any issues. And I've actually tested this personally with the Luxel APs. I've had 2 high-powered APs a room apart, no issues. Still does wireless handoff roaming even within a few dB, so it works very well. Let's see here. What's the next question? What is a good measurement tool? Is there any problems with too much power? I hope you have answer some of those. Insider, if you're using a laptop or an Android tablet, there's a lot of others out there as well. I personally like Insider for measurement tools. Too much power, you shouldn't have too many issues with too much power. It's better to overdo it than to underdo it. So without wireless controller, does the signal technically disconnect it when it moves from one AP to another. Without a wireless controller, what happens is the client device will hold on to that wireless access point, even though there's another one, a better one around. So with that being said, it should be the only other way to do that, even if it's the same SSID, it's not going to matter. It's not going to jump from one to the other without something that propagates that forward and tells it to, hey, there's a better one out there, you should probably switch. And you need something to manage that whole network. And some devices, some manufacturers try and do this software-based right inside the access points. The problem with that is that the access points aren't always communicating with each other. So how does it know that the other one is at a better signal strength? So you end up getting a delay, you get a drop down, and that really messes with stuff when you're watching videos, when you're doing control systems, and you have an app open. You need that to be a zero latency, zero handoff when you're doing roaming, meaning it's going to instantly switch from one to the other, and you're not going to drop that. You're not going to drop your internet signal. That's a huge thing. And I just answered the next question. Correct me if I'm wrong. There are at least one, possibly more advanced access points that have the controller tech built into them with allowing ceiling. Yes, but with doing that, it gets to be without having that central controller. Again, they're not constant. Even though they're constantly communicating, and they may have the ability to with the cloud service or other things, there is going to be some latency issues where if you have something constantly tracking those MAC addresses, that gets to be the hard part. So having that central controller is really the big thing. I've seen too many things happen with a lot of different manufacturers that try and do it inside their access points. Will you get going into 802.11k R&V in future webinars or recommend a resource? There are a lot of resources out there. I don't know if I'm going to get into that much detail because these are only 20-minute webinars and a lot to cover. If you want to talk more, I can chat offline with you on that one, though. So feel free to reach out to me. I may touch base on it, but I'm not going into a lot of detail in the future. Could you explain the advantages of an AC at wireless access point? AC wireless access point really is bandwidth. I mean, there's a lot of different features, but bandwidth is definitely one of them. Also, speed. You know, speed is definitely one of them. I mean, depending on the client access, the client device, you know, it really depends on that. We can talk more again if you want to reach offline. I'm not going to get too in depth on it right this second because I'd like to get you some info on that. So if you reach out to me, I'll get that for you after the fact. Do Android and iOS devices support 802.11 roaming handoff protocol? 802, both iOS and Android devices will work with this wireless controller with 802.11 handoff. Again, since the wireless controller is managing that and letting the devices know, you're not going to have that issue with handoff. Do all APs be set to the same channel throughout the home? When you're doing a wireless controller, you're having that, you can definitely do that. And actually, with the Luxel, you're actually going to set that up. You don't have to configure every access point differently. That's all done right inside the Luxel wireless controller, and it gets pushed out to all your access points. So it's going to have the same SSID, the same password, and they're going to be on the same channel. So you don't need to worry about doing multi-channel out there. Let's see here. Apple Airport Utility, does it only work with Apple Airport routers, or am I missing something? Apple Airport Utility, actually, you're able to use that to measure signal strength right from the iPad or iPhone. You don't need to have, it's built right in, and it's a tool that uses the antenna right inside your iPhone or your iPad to measure the signal strength. That would be the only reason you're using the Apple Airport Utility in this situation. Let's see here. Is one device better to use for signal strength than other? Laptop or phone? You know, that's an interesting question. It really depends. The laptop a lot of times has a better antenna than the phone, so you're going to get to be able to read that signal out there farther. But what I would recommend for measuring signal strength is the devices that are going to be used in that installation more, because again, they're going to be using wireless phones, tablets, those a lot more than laptops. I would definitely use the phone or the tablet to measure that, because it actually has a little less of an antenna than a lot of laptops do. So you get a better reading off the phone because it's going to be more for what they're using. Does it AC 1200 and 1 AP handoff. The new 1200 or the new wireless routers have the built-in controller built right into them, the wireless controller. So it does do zero handoff. The Luxel 1200 and 3100 have that wireless controller and can support up to 2 other access points with this zero handoff and zero roaming issues. Is there distance restrictions within AC? AC actually has the ability to support all previous. So when you talk about AC, it's really bandwidth capability. It's actually going to go down when you go from jump down to 2.4. You're not going to have restrictions on. It's still going to get the same distance as a low-powered or high-powered access, or not low-power, high-power. I'm sorry. There isn't any restrictions with AC with distance, no more than having a standard 2.4 high-powered access point. I hope that answered your question. Sorry, it came out a little wrong right there to begin with. So, is Luxel or any of the Capital other vendors working on a mesh Wi-Fi system similar to amplifier systems by Ubiquiti? No, because Ubiquiti doesn't use a wireless controller, and by doing so, or I'm guessing you're talking about maybe having the wireless controller does the mesh Wi-Fi system. That is the central system right there. The mesh system defeats the purpose of not having a wireless controller and doesn't work the way it should with the wireless controller. And again, we can get into that a little more. I don't want to go strictly brand related into this comparing, but we can definitely get into that a little more after this. But no, you do need a wireless controller. The mesh system, I don't recommend mesh systems because they don't work the way they should. Let's see here. What about the inability of the client to reach the access point due to its low transmission strength? I believe you're talking, correct me if I'm wrong, but I believe you're mentioning, okay, so let's say you have a high-powered access point, but your phone, you may be able to see the strength, but it's not able to transmit back. And again, this is why we say you never want to go below 70 dB. You go below 70 dB, you may be able to see the signal, but you're not going to be able to get to transmit back to it. That's where that negative 70, 75 dB, you want to stay within that range. Last question is the most of this plug and play? If you're mentioning about Luxel and setting up multiple access points, it really is plug and play. You're able to log right into the wireless controller and put in the SSID and the password and set the channel, and that's going to push all that out to every access point. So whether you have one access point or whether you have 10 plus access points, it's the same setup, and it doesn't take any longer to set up. Let's see here. Meshes for retrofit. Talk about Mocha. Why don't you give me a call on that after the fact? I don't exactly know. I'm not sure what you're asking on that question there, Daniel. So why don't you reach out to me and we can chat more after that. What's the coverage area of the wireless controller since it actually needs to be in communication with all devices connected to the network? What is the coverage area? The wireless controller is a hardwired device that's plugged into your network, and it's communicating and managing all of your wireless, not your wireless access point, but all of the clients connected to your wireless network. So to answer that, I guess the coverage would be the amount of coverage that your wireless access points cover. Let's see here. In an exterior setting, farm, campground, etc., do you recommend 2.4 or 5 gigahertz to get better range? Most access points, 2.4 is definitely give you better range, but a dual band access point is going to give you both 2.4 and 5 gigs. And with beam steering capability, you're going to actually be able to jump between 2.4 and 5 gigs depending on the signal strength. So, at least 2.4, if not dual band, with beam steering capability. And if you have a specific application, why don't you give me a call, and we can chat more about the specific application afterwards to figure out exactly what access points may work best for you. Wireless communication. You thought it was wireless communication with all peer devices. I believe you're talking about the wireless controller. It is communication with all peer devices, yes, with all the client devices, but it's actually communicating through every access point. So it sees every device that's connected to every access point, and it knows what access point it's connected to via MAC address and signal strength when it's communicating. So by doing so, it's managing every device on the network the wireless controller is, and telling it when to jump from one access point to the other. It's in constant communication with every device on the network. If multiple non-Luxel APs are deployed at a site, is it better to have them all in the same channel or separate channel as a general rule? And how does that affect roaming? If you don't have a wireless controller or something controlling all the devices on the network, what you would have to do then is set them to different SSIDs, or if you had them at the same SSID, you're not going to be able to jump between them. There will definitely affect roaming if you don't have something managing that. So that's, again, you want to make sure that you design a wireless system correctly to begin with. And if you guys have any questions, if you're getting into a project, definitely feel free to give me a call. I'd be happy to help design a system for you, make sure it's going to work out of the box, and so you don't have any issues in the future. Is the Luxel WAP hardwired to the controller? The wireless controller has a single access or a single Cat5 jack on it, RJ45 jack on there, and that's going to be connected somewhere in your network to the switch. All of your access points be plugged into any switch, any PoE switch or PoE injector, and then going to the switch. They don't have to be hardwired right to the access or right to the wireless controller. The wireless controller is just going to sit on the network somewhere hardwired. See here. Where can we go again to watch recorded webinars? This webinar and other webinars are actually on the Capital Sales YouTube channel, as where they get posted. There is links on our website as well, and if you go to, I can't even remember right this second, but there's a link right on our website as well. We do have all the trainings and PowerPoints saved on there as well. So. Any info on why Key Digital says not to use Luxel switches with their IP matrix products? They do support them. This is something that they had some settings messed up, and I've actually helped them rewrite the how-to videos on how to be able to get them to work. If you have any questions getting those set up, feel free to reach out to me. I'd be happy to help you walk you through how to set up and manage switches with the IP matrix products. So that's already been taken care of. That was something on their end, and was able to get them all the info, and everything works great on that. So, and again, that really had nothing to do with wireless, but it did have to do with Luxel. We'll touch base more on that next week as well. And again, guys, a lot of stuff. Wireless, there's so much info, and I only had 20 minutes to cover it. There's a lot of other stuff that we can go into. Just trying to hit the basics. Really, wireless is that wild, wild west, and a lot of times everybody's trying to do different things, and kind of understanding how it works is really helps a huge. I mean, if you don't know how it works when you're walking in, you're setting yourself up for issues. If you guys have any questions when you're going into that project or before or after you did a site visit and you have questions, definitely reach out to your local account manager at Capital or myself. I'd be happy to walk you through, see if there's any issues with your design, help you design the system, make sure that it's going to work right when you get there, so you don't have issues in the future. So I hope I answered a lot of you guys' questions. If you guys have any questions when you're walking in there, please give me a call. I'd be happy to answer anything you had. So again, thanks guys for hopping on. I'll let you guys get back to what you're doing, and hope to hear from you guys soon.